Center for BioMolecular Modeling is an instructional materials development laboratory. Founded in 1999 on the enabling technology of 3D printing, we create physical models of proteins and other molecular structures as a way to engage students in this amazing molecular world. A major component of our work is focused on the creation of professional development experiences for high school science teachers. In these week-long summer courses, we introduce teachers to a student-centered pedagogy in which physical models and other tactile teaching tools are used to capture students' interest in the molecular world and to encourage them to wonder about how things work at the submicroscopic molecular level. We believe that only when students begin to think deeply about this molecular world and ask questions that real learning can occur. And physical models are almost magical in the way that they can encourage students to focus and then to begin to ask questions. We're currently offering 3 summer workshops. The first, entitled Modeling the Molecular World, is our introductory workshop. This workshop sets the stage for the more advanced workshops that follow. In Modeling the Molecular World, we cover a wide range of topics, beginning with basic principles of chemistry contained in a magnetic water cup. We then apply these basic principles of chemistry to proteins as a way to understand how these linear sequences of amino acids fold up into complex 3-dimensional shapes. We then consider membranes and how these hydrophobic barriers separate the outside world from the inner workings of the cell, and the role of proteins embedded in these membranes that regulate the movement of small molecules across the membrane. We then turn our attention to the central dogma of molecular biology, and we model the basic processes of DNA replication, RNA transcription, and protein synthesis. And along the way, we tell stories, molecular stories of how some of the foundational concepts of biology that we teach to our students were first discovered. And finally, the last thing that we pack into this Modeling the Molecular World summer course is an introduction to protein modeling. You will learn how to access a PDB file from the protein data bank. This PDB file contains the atomic coordinates of every atom in a solved protein structure. You will learn how to use JMOL, a free molecular visualization program, to open this file and then design an image of that protein with features that tell the story of that protein. And any image that you can create, or your students can create, in this JMOL environment can then be converted into a physical model using 3D printing technology. And this brings us to our second summer course, 3D printing for the bioscience classroom. A subset of teachers who participate in Modeling the Molecular World will decide that they want their students to model a protein in our MAPS program. This 3-day workshop, which immediately follows the 5-day Modeling the Molecular World course, is intended for high school science teachers who want to begin to use their school's low-cost 3D printers to create physical models of proteins. This course will introduce you to the nuts and bolts of a 3D printer and get you started down that road. The third summer course that we're currently offering is entitled The Science and Ethics of Genome Editing. In this advanced course, we explore CRISPR, one of the hottest topics in biology today. This is the technology that we're going to use to begin editing the human genome. Probably the most important part of this workshop is to address the question, how are you going to connect this new topic, CRISPR, to what you already teach in a high school biology course? In answering that question, we will explore the structure of an endonuclease called Cas9. We'll model how this Cas9 endonuclease functions in an adaptive immune system in bacteria. And finally, we'll explore how researchers are now modifying Cas9 to be useful in making very specific changes to the human genome. And just as with Modeling the Molecular World, there will be stories about the process of science that document how many groups of researchers around the world first discovered this CRISPR system in bacteria, and then gradually, over a period of many years, understood how it works. So those are our summer courses. We hope you'll check them out. Check out our website for the dates, course fees, and how to apply for these. We look forward to seeing you here in some of those summer workshops. And the last thing I will say is that as terrific as these workshops are in terms of the content that you'll be exposed to, we consistently hear from teachers that their favorite part of these workshops are the other teachers that they meet in coming to the workshops. So these other teachers will quickly become your colleagues, your lifelong colleagues, and you'll be interacting with them over the rest of your careers as you share experiences and support each other in looking for innovative ways to engage your students in this amazing molecular work. Hope to see you soon.